Hi everyone, my name is Konstantin. I'm an engineer from VMware, and today I'm going to talk about extending the cloud service broker to include more services that it currently provides. So quick, brief, so we'll talk about the cloud service broker and the available services, how we can extend them. I'll quickly show you how to spin up a new broker pack for enabling other services, and then quickly gloss over common problems and pitfalls that you can come across. So first of all, what is Cloud Service Broker? It's an OSBAPI broker that you can register with Cloud Foundry, and it will provide you services from all sorts of IaaS platforms, for example, Amazon, Google, and Azure. So the way it does this is through something called a broker pack. A broker pack contains definitions of the said services and all the logic required for provisioning a service, binding, and so on and so forth. So it's effectively, it is backed up by Terraform. That's the back end. So in order to add new services, you should be able to create some sort of a Terraform script and wrap it into a broker pack. So how do you start? The Cloud Service Broker itself is also a CLI, not only a daemon. And it has tooling for kickstarting your broker pack and validating and building it. So without further ado, let me quickly jump into a demo. So yeah, so the way you start a new broker pack is you create a directory for it, and then you call Cloud Service Broker pack init. And quickly, what happened there is we have two new files with definition. One is the manifest. That's the manifest for the broker pack itself. I'll quickly do a quick modification to the template for the sake of the demo. And it will contain all the providers that are required in the Terraform, because they will be embedded in the broker pack as well. There's some environment variables and some boilerplate. And a brief service definition. So this is actually a working service. It doesn't do much. It just basically uses a random variable, but it contains a whole flow. So I need to go ahead and build the broker pack. So we'll take all the binaries and pack them. And now what I can also do is I can call validate. So this will make sure that I'm not, I need to say what exactly am I validating. It just makes sure that all the inputs and outputs match up, and there are enough definitions, and whatever I refer to exists. So once I have the broker pack, I can use the Cloud Service Broker again to boot it up. So this will create a server locally for development purposes, running here on port 8088. So I can go in a browser and hit my 8088. And see here we see documentation by default. Here we have the service name, as I've modified it. The weird GUIDs, please don't use those. Change it to something more useful, but I'll keep those for the sake of the demo. Now, I'll quickly deploy a Cloud Foundry. I will use the Cloud Service Broker CLI again, because it contains an OSBAPI client. So I can pretend to be the cloud controller. Client, and then I want to say provision, and then I need to specify the service ID. I'll copy that from here. I need to provide the plan ID, which is the same thing but with a 1. And I need to come up with an instance ID, because there's no cloud controller. I just need to come up with a random one, but just remember what it is. Oh, yeah, I also need to specify a username. So like in the documentation, it actually says here, this is an example, you should supply a username. And there we go. There's a 202, so we can say Cloud Service Broker client last, which will return you the last operation on an instance ID. Oops. That's my instance ID. Succeeded, so I can go ahead and do a bind. I will just reuse this command, but add a binding ID of 3. Bind. So we get our credentials with an email and URI. So effectively, when you bootstrap a broker pack in this manner, you get a fully working thing. You just need to fill in the Terraform that is inlined here. A better practice would be to extract it into a file name and then use the template ref instead, or better have a folder structure with proper Terraform definitions. But that's like, it is already working, so the only thing is missing is setting up the configuration, the parameter, and the Terraform. So that's it for the demo. Oh, the other way around. What do we get? Sometimes the problems that we get is problem actually almost like number one is out-of-band service updates. So because the Cloud Service Broker is backed by Terraform, it keeps the state. So sometimes if you make an operation outside of the Cloud Service Broker without updating the state, it will try to do funny things that could really cause all sorts of calamity. And I do understand that sometimes you really, really need to go out of band because there is no, like the properties that you need to change are not available in the broker pack and so on and so forth. So yes, in this case, you will need to find a clever way of reintegrating the instance with a broker because the current instance would probably be unusable. The second, the lifecycle prevent destroy in Terraform is very, very handy, especially when you're dealing with databases. So this would prevent your instance from being destroyed because you've specified some parameter that will cause the instance to be destroyed. This lifecycle, it will be removed automatically when you actually call a CF delete. Right? So it's safe to put this lifecycle in the resource, and it's very useful. And we support actually deleting instances that have it. Also, the configuration and Terraform binary upgrades, the parameters that you use get cached. Again, that relates to the Terraform state that you have. So if you decide to remove a parameter or rename or introduce a parameter with a default value, sometimes this may cause unexpected side effects. So that has to be carefully planned. Last but not least, the database binding user permissions. Because of the semantics, how services are generally used in Cloud Foundry, it's expected that if you create a binding, then you remove a binding, create another binding, that new binding should have all the access to all the data in the database. But because you're creating the user in Terraform, you might need to have additional steps to make sure that the new user will get access to the old data so that it won't get orphaned. We ended up creating a custom Terraform providers just for that, bindings for Postgres and MySQL. And last one about parameter naming, it's the best idea is to actually follow the Terraform parameter naming. And the reason why is because then you can just reuse the Terraform documentation for these purposes. So that's it. Sorry. Here are some useful links. They are all in the slides up on the schedule. They talk more about what the specification looks like, what would you need to actually do, how do you configure inputs, outputs, and all the stuff that I couldn't fit in a 5-minute presentation. And we have the links to the Amazon, Azure, and Google Cloud broker packs. So yeah, PR is welcome. And thank you. Any questions?